Hey there, Mr. Weaver here, and this is Module 11, Lesson 4, Solving Quadratic Equations by Factoring. After this lesson, you need to be able to solve quadratic equations by using the square root property, solve quadratic equations by factoring, and sketch graphs of quadratic functions by using the zeros, and write equations of quadratic functions given their graphs or roots. Let's learn. Solving quadratic equations by using the square root property. So our key concept here is the square root property. Essentially what this means is if you have a quadratic equation in the form of x to the second power equals a number, all you have to do to solve for x is to take the square root of each side. And this works for any number that is greater than or equal to 0. So when we do that, we end up with x equals plus or minus the square root of that number. So for example, if x squared was equal to 49, then x would be equal to plus or minus the square root of 49, and then that square root of 49 is equal to 7. So x would be equal to plus or minus the square root of 7. If the number that's inside the square root is a perfect square root, you'll have an exact answer. Like here we have positive 7 and negative 7. If it is not a perfect square, so let's say this was 50 instead of 49, then we'll have to either approximate the square root or we'll just use a calculator. And you'll see those examples where the answer is written like such. So like the square root of 50 would be 7 point something. Example 1, use the square root property. Solve y plus 5 quantity squared equals 21. Sometimes when we're solving for our quadratics, we'll just have an easy value like y squared equals 21. Other times you might have things in parentheses like this, where we have y plus 5 squared. To solve, we're going to follow the same thing, pretending this whole thing is just like a single variable, at least at first. So we're going to use the square root property and just take the square root of both sides to begin to solve, since this part to the second power is by itself. If there were other things added to the end of it, so maybe there was like a plus 2y plus 5, then we can't use this property quite yet. But if the part to the second power is by itself, then you can always just take the square root of both sides. So if we do that, we end up with what was inside the parentheses, y plus 5. That would be equal to the plus or minus square root of that number. Then to solve for our variable, so if I wanted to get y by itself, I would just subtract 5 from both sides. Now, generally you're going to see this number in front, so we would have negative 5 plus or minus the square root of 21. Then finally, to get both roots, we would separate that out, so we'd have negative 5 plus the square root of 21 and negative 5 minus the square root of 21. This means our solutions would be the plus version or the minus version of the same thing. If we use a calculator to calculate that out, that's where we can really tell the difference between our answers. So plus the square root of 21 is negative 0.42, whereas if we had negative 5 and subtracted the square root of 21, we end up with negative 9.58. Clearly different numbers, even though they might look the same when they're written as a square root. Check your understanding, complete both problems, and select all solutions. Pause the video now and complete the check. Check your answer. For the first one, we should have got negative 2 and 6. If we take the square root of both sides, we end up with x minus 2 equals the square root of 16 is positive or negative 4. Then we would add 2 to both sides. So I'm going to swing that out front. Positive 2 plus or minus 4. So x would either be equal to 2 plus 4, or x would be equal to 2 minus 4. 2 plus 4 is our 6. 2 minus 4 is our negative 2, which are the two we should have picked. For the second one, y plus 18 squared equals 77. Take the square root. The square root of 77 is not a perfect answer, so y plus 18, we'll just leave it as the square root of 77 for now. Subtracting 18, we would end up with negative 18 plus or minus, I should have put that up here, the square root of 77. So when we add the square root of 77, we get negative 9.23, which was B. And when we do negative 18 minus the square root of 77, we get negative 26.77. Example 2, solve an equation by using the square root property. Our real context here is egg drop. During the egg drop competition at Annika's school, students must create a container for an egg that prevents the egg from breaking when dropped from a height of 30 feet. The formula h equals negative 16t squared plus h sub 0 can be used to approximate the number of seconds t it takes for the container to reach a height from an initial height of h0 in feet. Find the time it takes the container to reach the ground. So at ground level, h would be equal to 0, and the initial height here is 30 feet. So that means h sub 0, which stands for the initial height, is equal to 30. So let's plug those two things into our equation. We want our height to be 0, because that's when it hits the ground, starting from an initial height of 30. That's where it told us in the original formula. Now, we want to solve for the time that it takes to reach the ground. So I'm going to try to get t by itself. So the first thing I would need to do is subtract that 30 from both sides. That way it's gone. So I have negative 16t squared equals negative 30. Then I would divide both sides by negative 16. And I'd end up with t squared by itself, which is what we need to use the square root property. So negative 30 divided by negative 16 is 1.875. And it becomes positive because it's a negative divided by a negative. And that's important because we have to be able to take the square root of a positive number. Finally, using a calculator to take the square root of both sides, we would end up with t is about 1.37. It would also be negative 1.37 But since we are talking about time here, we need to use the positive value. So it took 1.37 seconds for the container to reach the ground. And just like all the methods that we're going to use to solve these equations going forward, you can always check your answer using the graphing method with decimals and seeing when the graph crosses the x-axis. Let's learn solving quadratic equations by factoring. Our key concept is the zero product property. So what this property says, and it's super important when solving by factoring, if the product of two factors is 0, then one of those factors must be equal to 0, because anything times 0 is 0. So if you had two numbers, a and b, so a times b, then either a or b, or both, have to be equal to 0. That way you get 0 as your answer. It doesn't matter what the other one is. If one of them is equal to 0, then the total is 0. And that's going to be important going forward. As a review, we also have 4 different ways that we learned about factoring. If you forgot these, go back to Module 10, Lessons 5, 6, and 7 for a review on how to factor these different methods. We had the distributive property, so this is where you factor out a greatest common factor from the first part and the second part. It should be the same in both, and then you put the first two things back together. We had factoring quadratic trinomials, where we're looking for the factors that multiply to get a and c, but yet add to b. We had factoring for differences of squares, where we have the same thing with opposite signs in there, in order for there to be no middle term. And then last, we had perfect square trinomials, where it's the same thing both times. Example 3. Solve a quadratic equation by using the distributive property. Solve 4x squared minus 12x equals 0. Check your solution. So we have 4x squared minus 12x equals 0. For the distributive property, we are trying to factor out the greatest common factor. For that, we can take out a 4 from both. They're both divisible by 4, and there's an x in each we can take. So we can take out 4x. What's left? We have x minus 3. Then, because of the zero products property, one of these two things must be equal to 0 because we're saying it equals 0. So either 4x equals 0 or x minus 3 equals 0, or both of them. Then our last step here is just to solve our equation for the variable. So if 4 times something equals 0, that x value could be 0, or x minus 3 equals 0. So if I added 3 to both sides, x would be equal to 3. Now we need to check our solutions. So we're going to do that by substituting them into the original equation. If I plug in 0, I get 0 squared times 4, which is still 0. 12 times 0 is 0. So 0 minus 0, is that equal to 0? Yes. If I plug in 3, 3 squared is 9. 9 times 4 is 36. 12 times 3 is 36. 36 minus 36, is that equal to 0? Yes. So I plugged my numbers back in. They both equaled 0. So my solutions must be correct. Example 4. Solve a quadratic equation by factoring a trinomial. Part A. Solve x squared minus 2x minus 8 equals 0. Check your solution. So here I have my quadratic trinomial. For factoring a trinomial, remember, we want to find the numbers that can multiply to a, which is 1 times c. So 1 times negative 8. I'm trying to multiply to get to negative 8, but I'm trying to add to get that b term. So I want to add to get to negative 2. How can I do that? Well, negative 8 just means that they're opposite signs. So I would either have positive 1 in negative 8 or negative 1 in positive 8, or the same with 2 and 4. How can I get negative 2? Well, 1 and 8 would either give me positive 7 or negative 7, depending on which one is positive and negative, not negative 2. I can get negative 2, though, if I have negative 4 and positive 2. So those must be my two numbers. We take those two numbers then, and we just plug them into the parentheses, positive 2 and negative 4. And again, we just plug those numbers in when a is equal to 1. If the a value was a different number, we'd have to go through the process of splitting it and finding the GCFs. But here we can just plug them in. Now, using the zero product property, I know that one of these two things must be equal to 0. So either x plus 2 equals 0 or x minus 4 equals 0, or both. Solve for x each time. So here I would just have to subtract 2 and I'd get negative 2. Here I would have to add 4 and I'd get x equals 4. Again, we were wanting to check our answers. So when I would do that, I'd plug in my values. So negative 2 squared minus 2 times negative 2 minus 8. And I want to see if I get 0 as my answer. So negative 2 squared is 4. Negative 2 times negative 2 is positive 4. So 4 plus 4 is 8 minus 8 equals 0. That one works. If I plug in positive 4, then I would have 4 squared, which is 16, minus 2 times 4, so minus 8, which is 8, and then still subtracting 8 more. Do I get 0? Yes. 16 minus 8 again is 0. So my solutions would be negative 2 and positive 4. Part B. Use the roots of x squared minus 2x minus 8 equals 0 to sketch the graph of the related function. If we were graphing this, we would graph negative 2, 0, and 4, 0. So these were your two solutions for x, and we're going to make them the zeros. So we would plot those points on the graph. Here's negative 2, 0. Here's 4, 0. So remember, in graphing, the solutions are where it goes through the x-axis. Those are your x-intercepts or zeros. Our vertex here we could figure out would be halfway between these two for our axis of symmetry. So it would be at 1. And then if we plugged in 1, we would get negative 9. So we'd plot that point down here, 1, negative 9 for our vertex. We can tell our a value is positive because even if this wasn't graphed yet, I can tell my graph would be opening upward. So a would be positive. And then I could also find some other points, such as our y-intercept right here is at -8. And I could also use some symmetry, thinking about where our axis of symmetry is. If that's there, this one would have to be here. And then I have my 5 points to graph my parabola. So when you're graphing or creating a graph from an equation, you can use the zeros. From there, you can find the vertex. The y-intercept is usually somewhere in the equation. And then from there, plot those points, you can get your graph. Check your understanding. Solve x squared minus 10x plus 24 equals 0 by factoring. You do not need to sketch the graph for this one. Pause the video now and complete the check. Check your answer. So you should have got x was equal to 4 and x was equal to 6. If I'm doing this, I'm finding the numbers that multiply to 24, 1 times 24, but add to -10. So what would my two numbers be? Well, 3 and 8 give me 11, so 4 and 6 would give me 10. I need it to be -10, so -4, -6, x minus 4, x minus 6. Solving, x minus 4 would be equal to 0, so add 4 to both sides, x is equal to 4, and then x minus 6 is 0, add 6 to both sides, so x will be equal to 6. Example 5. Solve a quadratic equation by factoring a difference of squares. Solve 49 minus x squared equals 0. Check your solution. If you see a difference of squares here, like this, most likely you'd be able to just add x squared to both sides, swing it over, and solve by using the square root property. But here's how we could do it without that. So when we saw a difference of squares, when we factored it, we just took the square root of both things. So square root of 49 was 7, square root of x squared was x, and then make them opposite signs. So 7 plus x and 7 minus x. We can quickly get it into that factored form, and then using our zero product property, we can set each equal to 0. Then to solve for x, we would subtract 7 for one of them and add 7 for the other. So those would be our two roots. As I said before, if we had swung that x squared over here by adding it to both sides, taking the square root, x squared equals positive or -7. So either way, it works. We can check by plugging it in. If I plug in 7, 7 squared is 49, 49 minus 49 is 0. If I plug in -7, -7 times -7 is positive 49, 49 minus 49 is 0. So both of them work, they are both solutions. Example 6. Solve a quadratic equation by factoring a perfect square trinomial. So solve 25y squared minus 60y plus 81 equals 45. Check your solution. So first, in order to solve any of these by factoring, we need to get this part equal to 0. So I need to subtract 45 from both sides. That way it's equal to 0. So if I subtract 45 from 81, I get 36. From here, we could solve it by factoring. Our a value would just not be equal to 1, but they are telling us that this is a perfect square trinomial. And if you remember, in perfect square trinomials, a is a perfect square, 5 times 5 is 25, c is a perfect square, 6 times 6 is 36, and the middle is doubled if you multiply those two things together. So 5 times 6 is 30, times 2 would be 60. So this is a perfect square trinomial. When we factor it, we take the square root of the first part, so it would be 5y, and the square root of the c value, so 6. So this would be 5y minus 6, quantity squared. That equals 0. Now we can use the square root property or zero product property to set both parts equal to 0. Here it's showing taking the square root. I would end up with what's inside, and the square root of 0 is just 0. If you did positive 0 and negative 0, you would get the same answer both times. It's a double root. So when I'm solving here, I would add 6 to both sides. So I'd have 5y equals 6, divide both sides by 5, and so we would get y is equal to 6/5. And if I wanted to make that a decimal, it would be 1.2. And I could check by plugging that back in. Would I end up with 45? Yes, I would. Check your understanding, read through the situation, and find the volume of the prism. As a quick hint, S, standing for surface area, is equal to perimeter times the height. So we have our perimeter around the base of your prism before it goes vertically, plus, and then 2 times the area of whatever the base is. So that's that part right there. And then finally, to find your volume, the area of the base, so down here, times the height. But only figure out the volume once you know what x is. Pause the video now and complete this check. Check your answer. You should have got C, 180. Now, to get that real fast, we have the volume, the height of this, I'm just going to draw 1, is 15. The length is x plus 4. And its width is x. So I want to find the surface area first, knowing that it's 264. That is equal to the perimeter, which is x plus another x, so 2x, plus a third x and a fourth x, so 4x. And there's a plus 4 on both, so 4x plus 8. But it's not just the perimeter, it's the perimeter times the height, which is 15. Also, we have to do 2 times the area of the base. So plus 2 times x plus 4. So this is actually a very complicated problem to set up, but solving for x after that isn't as complicated as it looks. So I'm going to distribute stuff out. So 15 times 4 is 60 with the x. 15 times 8 is 120. Here I have x times x, which is x squared times 2. So 2x squared. X times 4 is 4x times 2 is 8x. So just by distributing, they're all positives. My numbers become pretty easy to use pretty quickly. This is still equal to 264. I'm going to combine like terms. So I have 68x. I have 2x squared out front. And to get it equal to 0, I'm going to subtract 264. I end up with negative 144. And just like in the previous example, I can see these all are divisible by 2. So if I factor out a GCF of 2, then I'm just left with x squared plus 34x minus 72. And even though these numbers are still rather large, I don't need to do as much work anymore because now my a value is 1, which means whatever my factors end up being, I just stick them in parentheses with the x. So what values multiply to negative 72 but add to 34? That would be positive 36 and negative 2. So I'm going to put those two things in, 36 and negative 2. Now, those are both equal to 0. So x plus 36 equals 0. X must be equal to negative 36. Or x minus 2 equals 0. X must be equal to 2. If we're thinking about this context, can I have a side length here of x be negative 36? No, that doesn't work. So 2 is my only viable option. So if I'm plugging in 2, that means that this side here is 2. 2 plus 4, this side here must be 6. So now my volume is just 15 is my height times my base, which is 6 times 2. 6 times 2, 12. 12 times 15 is 180, which we said was C. Let's learn writing quadratic functions given the zeros. So our key concept here, writing equations of quadratic functions. Our first step, we're going to find the factors of the related expression. Then we're going to determine if the a value is positive or negative. And then finally, use another point on the graph to determine the value of a. If the vertex or the y-intercept are easy to find, we should probably use one of those. Example 8, write a quadratic function given a graph. So let's write a quadratic function for this graph. First, let's find the factors, which means we need to find the zeros. So we have our two zeros here where they cross the x-axis. So we cross at negative 2 and at 6. Okay, if we look here, each of them is counting up by 2. So this is our negative 2, this is 6. Which means if those were the answers going backward, unsolving essentially for when it's equal to 0, we must have had x plus 2 and then x minus 6. If you didn't notice in the other examples when we were solving for x, the answer was always like the opposite sign of what was in parentheses. And if it was just x by itself, it was the same number. So here we have x plus 2 and x minus 6. This means that the related function is going to be f of x equals whatever the a value is, we'll figure that out in a second, times the two factors we just figured out. So next, let's figure out if a is going to be positive or negative. Well, this graph opens going up. So it has a minimum, it's opening upward, a must be positive. And then finally, we're going to use another point on the graph to determine the value of a. So we can see here we have our vertex at 2, negative 8, or if we wanted, we could probably use this y-intercept at 0, negative 6. Either way, it would work. Once you figure out a point, you're going to take these two values and plug them in for x and y, or for x and f of x. So f of x was negative 8, plug in 2 in both places for x. From there, we're just going to solve for a. So 2 plus 2 is 4, 2 minus 6 is negative 4, 4 times negative 4 is negative 16. Now last I would just divide by negative 16 to both sides. A gets by itself. What's negative 8 divided by negative 16? That ends up being positive 1/2. So a is equal to 1/2. So one of the equations for this function, we could just write it with our a value and then our two factors, or we could use the FOIL method that we learned about in module 10 and multiply things out. And when we do that and then times it by 1/2 at the end, we would end up with a function of f of x equals 1/2 x squared minus 2x minus 6. Check your understanding. Which quadratic function represents the given graph? Please do not use Desmos to solve this at first. And as a hint, each line here is counting by 2. Pause the video now and complete the check. Check your answer. You should have said A. Here's how we get that. So first of all, if we're counting by 2s, this one here is at negative 4. So I would have a factor of the opposite sign with the number. And if we're counting by 2s, this is halfway. So this must be at x opposite sign with the number. So x minus 1. Then to figure out our a value, I'm looking for another point on here that works nicely. I see one down here that looks like it goes through. Counting by 2s, that point is at 4, negative 6. So when I'm trying to figure this out, I need it to equal negative 6. And I'm going to plug in 4. So 4 plus 4 would be 8. 4 minus 1 would be 3. 8 times 3 is 24. So I would have 24a equals negative 6. divide by 24, and I would end up with 1/4. So a must be equal to negative 1/4. Now, if we look at our choices, they are multiplied out. So I'm going to FOIL this out. I have x squared for the first, outside minus 1x, inside plus 4x, last minus 4. And then I need to do 1/4 of that. So negative 1/4 x squared, which eliminates b and d since they're both positive. Negative, these two together would be 3x. So negative 3/4 x. That's negative, that's positive, that's our difference. And then negative 1/4 times negative 4 is positive 1. So after we multiply out that negative 4, after we multiply out that negative 1/4, we end up with our final format of our answer.